3 stone blocks sit in a wall in Lebanon. Each one weighs around 800 tons. They are longer than a city bus, taller than a person, and fitted together so tightly that the joints are difficult to see from below. They were cut from a quarry almost a kilometer away. Then ancient builders moved them across uneven ground and placed them inside the platform of one of the largest temples in the Roman world. No surviving text explains exactly how they did it, and the mystery becomes even stranger in the nearby quarry. There, archaeologists found blocks that were larger still. One weighs around 1,000 tons, another may weigh more than 1,200, and beneath them, partly hidden in the earth, lies a stone estimated at roughly 1,650 tons. It is one of the largest blocks ever cut in the ancient world. The unfinished stones never left the quarry, but 3 slightly smaller giants did. They reached the temple. They were placed into position. And more than 2,000 years later, they are still there. This is Baalbek, and its stones have turned an ancient construction site into one of archaeology's greatest engineering questions. Baalbek stands in Lebanon's Bekaa Valley, between mountain ranges that once carried roads linking the Mediterranean coast with Syria and the interior of the Middle East. Long before Roman builders arrived, the site was already sacred. During the Hellenistic period, it became known as Heliopolis, the city of the sun. Under Roman rule, the old sanctuary became a monumental religious center where pilgrims worshipped a local divine triad identified with Jupiter, Venus, and Mercury. Roman architecture was built over traditions that were already ancient. If ancient construction mysteries are why you are here, subscribe and turn on notifications. Because the most famous part of Baalbek is not the temple standing above the ground. It is the platform beneath it. The main sanctuary was the Temple of Jupiter. Only 6 of its enormous columns remain standing today, but even those fragments reveal the scale of the original building. The columns rose about 20 meters high. They surrounded a temple designed to dominate the landscape and impress anyone entering the sanctuary. Yet before the columns could rise, the builders needed a stable terrace. The hill beneath Baalbek was not a simple flat surface. The temple platform had to support immense weight, while creating a level ceremonial space. Roman engineers built retaining walls and filled the interior to form a raised foundation. In the western wall, they used a row of massive stone blocks. Above a lower course of large masonry sit the 3 stones now called the trilithon. Despite the name, they are not arranged like the standing trilithons at Stonehenge. They lie horizontally beside one another. Together they form a section of wall nearly 60 meters long. Each block is commonly estimated to weigh around 800 tons. Their scale becomes clear only when a person stands beside them. Unlike the abandoned giants in the quarry, these stones were fully cut, transported, and built into the terrace. The quarry lies southwest of the temple complex, less than a kilometer away. That distance sounds short, until the object being moved weighs hundreds of tons. The limestone was available close to the sanctuary, which reduced the journey. But close did not mean easy. The builders first had to separate a block from the bedrock. Ancient quarry workers cut trenches around the sides using iron tools. They followed natural layers and fractures in the limestone whenever possible. Wedges could be driven into prepared lines to help detach the lower surface. The process required careful planning because a hidden crack could ruin months of labor. One mistake could split the stone after hundreds of workers had already shaped it. Evidence in the quarry shows that the builders were willing to attempt blocks larger than anything they ultimately placed in the temple. The best known is called the Stone of the Pregnant Woman. It remains tilted inside the quarry, still connected to the ground along part of its lower surface. Local legends gave the stone its unusual name. The archaeology tells a simpler story. The block was prepared for transport, then abandoned. Later investigations revealed another giant nearby, estimated at more than 1,200 tons. In 2014, excavators cleared soil beneath the famous stone and exposed an even larger block. It measured roughly 20 meters long, 6 meters wide, and at least 5.5 meters high. Its estimated weight was around 1,650 tons. It may be the largest known stone block cut by ancient builders. But it never moved. That difference matters. The quarry stones show the upper limit of what the builders attempted. The trilithon shows what they actually achieved. Why would anyone choose blocks this large? Smaller stones would have been easier to quarry, transport, and replace. One explanation is structural. Baalbek's platform had to support a colossal temple on uneven ground. Long blocks could tie sections of the retaining wall together and spread pressure across a wider area. Fewer joints also meant fewer weak points. But practical need alone may not explain the scale. Roman imperial architecture was designed to communicate power. A visitor approaching Baalbek was meant to feel small. The walls, stairways, courtyards, columns, and carved stone all announced that the empire had the money, labor, and organization to build beyond ordinary limits. The giant foundation blocks were partly hidden from the most important ceremonial spaces. Yet their presence still supported the message. The temple stood because Rome could command stone, people, and landscape on an extraordinary scale. So how were the blocks moved? The honest answer is that no complete construction manual has survived. Archaeologists can reconstruct methods from quarry marks, Roman engineering knowledge, experimental work, and the shape of the terrain. But no single explanation has been proven in every detail. The most likely first step was to avoid lifting the stone. A block weighing 800 tons would exceed the safe capacity of a normal Roman crane. Even groups of cranes would create enormous problems with balance, ropes, and the strength of wooden frames. Instead, the builders probably dragged the blocks while keeping them supported from below. Earth and stone could create a controlled ramp between the quarry and the temple, firm enough to resist sinking and smooth enough to protect the block. A wooden sledge is one possibility. Heavy beams beneath the stone could distribute its weight. Lubricated tracks, wet clay, or other low-friction materials may have reduced resistance. Wooden rollers are often imagined in popular reconstructions, but rollers under a block this heavy would face crushing, turning, and control problems. They may have helped during limited stages, but a sledge moving over prepared tracks is often considered more practical. The pulling force did not have to come from one enormous team standing in front of the stone. Roman engineers understood capstans, pulleys, anchors, and winches. A capstan converts the walking force of people or animals into controlled pulling power around a vertical drum. Several capstans could work together. Ropes attached to the sledge could be shortened slowly, moving the block a small distance at a time. Workers would reset the system, inspect the track, and pull again. The movement may have been measured in centimeters rather than meters. That would still be progress. The builders did not need speed. They needed control. The stone also did not have to be raised from ground level to the finished wall in one lift. The terrace could be built around it. An earthen ramp may have brought the block close to its final height, while lower courses of masonry were still under construction. Once the giant stone reached the correct level, levers and packing blocks could shift it sideways. Workers could raise one edge slightly, insert support, then repeat the process on the other side. By alternating these movements, a massive object can be advanced without ever hanging freely in the air. The final fit would require surveyors, stonecutters, and supervisors to work together. Its surfaces had to match the stones beside it, and the entire process had to avoid a crack that would make the block useless. This was not a secret machine. It was a system. Quarrymen understood the stone. Carpenters built sledges, beams, and capstans. Rope makers supplied cables. Laborers prepared the road and moved earth. Surveyors controlled direction and level. Engineers planned the sequence. Officials organized food, wages, tools, and replacement materials. The real technology was the ability to coordinate all of those people, for as long as the job required. Baalbek was built over more than 2 centuries by different officials, architects, priests, and workers. It developed in stages, which helps explain how an extreme idea became possible. The builders could test methods on smaller blocks. They could improve the quarry route. They could abandon stones that revealed cracks or became too difficult to move. The unfinished giants preserve the choices and mistakes of an ancient workshop. The stone weighing 1,650 tons is often presented as though ancient people moved it and then somehow lost the technology. They did not. It remained in the quarry. Its lower surface was not fully freed, and its weight is an estimate based partly on the stone still hidden underground. The 3 blocks in the temple are smaller, though still astonishing. There is also no strong archaeological evidence that aliens, giants, or an unknown advanced civilization built the Roman terrace. Baalbek had an older sacred history, and Roman builders reused a site that already mattered. But the colossal construction visible today belongs to the Roman sanctuary and its long building program. Removing exaggerated claims does not make the achievement less impressive. It makes the real problem clearer. Ordinary human beings, using iron tools, wood, rope, earth, mathematics, and organization, moved stones that modern observers struggle to imagine moving at all. After the Roman period, Christian buildings appeared. Later rulers fortified the sanctuary, and earthquakes damaged its columns and walls. The Temple of Jupiter collapsed until only 6 columns remained standing, yet the lowest part of the platform survived. The giant blocks had been placed so effectively that they outlasted the temple they were meant to support. Today, visitors can walk beside the wall and see the joints between the trilithon stones. Then they can travel to the quarry and stand near the unfinished blocks. The short distance between those 2 places contains the entire mystery. At one end is intention. At the other is achievement. The quarry shows stones still attached to the earth, silent evidence of plans that were stopped. The temple shows 3 stones that completed the journey. We may never recover the exact number of workers, the shape of every sledge, or the order in which every rope was tightened. But the surviving evidence reveals enough to reject the idea that the stones are impossible. They were difficult. They were expensive. They were dangerous. And that was probably the point. Baalbek was built to make human power look almost divine. 2,000 years later, most of the people who created it are nameless. The emperors who funded the work are gone. The priests who climbed the temple steps are gone. The wooden machines, ropes, ramps, and scaffolds have vanished. Only the stone remains. 3 blocks, each weighing around 800 tons, still resting where ancient builders placed them. And less than a kilometer away, an even larger stone is still waiting in the quarry, exactly where they decided it would remain. The next investigation is waiting on screen now.